Get up, stand up. Stand up for your right. Get up, stand up. Don't give up the fight. Get up, stand up.
Shut up, clock in and load up.
Stand up for your right.
Yeah, what up YouTube, what up? Jolioli coming at ya for Custom Girl. This 18-hour channel designed to you for patients and adults. In this episode we're going to be talking about Unit 10 Modern Physics. I'm going to hand it off to my man Smelly, who's going to tell you guys a little bit about what we're going to be doing today.
Alright, we're going to be doing some dank stuff. That's what I hear right now. We're going to be doing some Albert Einstein, my brother, E equals MC squared. That's what we're going to be doing. And some K-Max. Can't forget about the K-Max.
Yo, let's not forget, what's today? So we'll see you guys on the flip side.
Crank that song, now I mean you. Crank that song, now I mean you. Crank that song, now what? Soulja Boy, I been it. Why me crank it? Why me crank that song?
Oh, what up, dude? Once again, didn't see you there. Happy 420. We out here at the Lakeway Skate Park. Mall grabbing it up, yo. We just about to go shred because who can do some physics while your mind is just preoccupied wanting to shred? Yo, let's go get it. Go.
So what is it we're going to be doing today?
Alright. So like I said already, we need to make sure it is our mission that we teach every single person in this world physics. So how we're going to do that is we're going to go around and we're going to find the most confusing concepts of Unit 10 and we're going to teach them in our video. So we've got the 4 main formulas for Unit 10 written down on a sheet of paper, and we're out here at the Lakeway Skate Park. We're also going to go some other locations, ask people what they find the most confusing about this sheet, and we're going to cover that. Alright, so we're going to go ask our first person some questions about physics.
Hi, bro. How are you?
Want to answer some questions about physics?
Oh, yeah, no problem.
So, out of these 4 formulas, which one looks the hardest to you?
I'm gonna go with that one.
That one?
One above it.
That one.
Yes, sir.
The K-Max.
No. This one, the little triangle.
Oh, the lambda?
Yep, the lambda.
Alright, what do you think the lambda stands for?
Bro. Lambs. Is it actually?
Yeah, what do you think the H stands for in E equals HF? Alright, that's good, that's good. Go back to your hand, buddy. You're gonna have some more stupid idiots around here. Let's go.
Second victim.
Oh, crap. Hashtag Hall of Meat.
Dang it, not again.
Alright.
Alright, yo guys, what up? So, we're with Lake Travis High School Astrophysics 4 AP. That stands for Advanced Placement if you didn't know. So we're doing a project right now. Pretty much what's gonna happen is I'm gonna ask you, what do you think is the hardest formula on this sheet? You're just gonna tell me. Both of you guys can get a go. And yeah, it's gonna be it. Sound good? Alright, 420 dank. Alright, so out of these 4, which one do you think is the hardest? E equals MC squared. Common. You know, a lot of people have heard of that formula, but believe it or not, it's not hard at all. Okay, what about you?
This one.
Oh, good choice, good choice. All right, so now we got the interview out of the way. Do we have your permission to use your face on camera?
Yes, sir.
Good to hear. Great to hear. All right, happy 420, guys. See ya. Oh, God, should I call your mom? You want me to... Bro, you want me to call your mom? You want me to call your... Oh, my... Stay down. It's all.
I need my knees.
Alright guys, so in this installment of the video, let's just go ahead and give you an overview of what we're going to be doing throughout the video. So we're going to cover the most 3 challenging aspects of Unit 10 Modern Physics. Go.
Alright, so we're about to do some good old free response problems. They're really fun. But since today is 420, we're going to have to take a moment and honor 420. Oh, yeah. Alright, now that we've done honoring 420, let's get started. So first I'll read this problem out.
In a photoelectric experiment, light is incident on a metal surface. Electrons are ejected from the surface, producing a current in the circuit. A reverse potential is applied in the circuit and adjusted until the current drops to 0. That potential at which the current drops to 0 is called the stopping potential. The data obtained for a range of frequencies are graphed below.
And there's the graph. So for number A,
For a frequency of light that has a stopping potential of 3 volts, what is the maximum kinetic energy of the ejected photoelectrons?
alright, so what we want to do first, we want to get the formula K max. Ooh, come get another lefty angle. So K max equals E times stopping potential. Alright, so since this is stopping potential right there, we simply have to do this. K max equals 1.6 times 10 to the negative 19th times 3. Alright, and what we get from that is K max equals 4.8 times 10 to the negative 19th joules. Make sure to circle that one and slap a good old joules on the end, or else you're not going to get the credit, you know what I'm saying? Know what I'm saying? Alright, now let's move on to numero B. We're going to have to use the very esteemed formula known as EVS equals HF minus work function, my bad. Let me take another break to honor 420. Alright, let's go. Anyway, so to get the slope of this one, since these are multiplied by each other, you're going to want to divide E over. So then you get stopping potential equals H over E times F minus that right there. Work function over E. This functions as your Y, this functions as your slope, so H over E equals slope. And this functions as your X, and this functions as your intercept. Alright, say what you want to do. Your Y-intercept, that is. So then you're going to write slope equals H over E. Alright, make sure to also write that rise over run equals slope as well. That will get you some well-needed points, because we all know you guys aren't smart enough to get points. So you're going to really need to write that on every single problem to get the points, to get the 2 that you're striving for. Okay, good. Alright, so to find slope, we're going to have to take some points on the graph up here. That is stopping potential in the y-axis and frequency in the x-axis. Anyways, we get this, and we get 2 is rise over run, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 times 10 to the 14th. So then we get the beautiful number, since rise over run, 2 over 5 times 10 to the 14th. Okay. And we have equals h, since we are solving for the Planck's constant. Which, why would we need to solve for? We already know that, but physics, because AP sucks. So now, since we're solving for that, we then put, since it is over E and we know E is 1.6 times 10 to the negative 19th, we can simply cross multiply, and we end up with H equaling 6.4 times 10
to the negative 14th joules times seconds.
One left out. Unfortunately, we did run out of battery, but
Yes.
don't worry, we got you covered.
Okay, so once you get that and you use those units, then
I did. I think you need to go back.
what do you mean?
Just to recapitulate on where you were.
Alright, so where we left off due to our lack of battery, we were finding the slope and we had calculated it using h over e. So we used these points, rise over run, which is 2 over 5 times 10 to the 14th. Set that equal to h over e, substitute e for 1.6 times 10 to the negative 19th, and you cross multiply it out and you get this using those units. Alright.
I saw it, dude.
Did. Alright, so what you want to do now is, now you want to find the work function. The work function is this. That's the work function.
Wow.
Wow. Anyways. You use k max.
That came in, right?
No, that's a different, that's for physics C.
Q?
Yes. Minus, so HF minus that one, the OG Kmax formula. So then, Kmax equals 0. So you can, 0 equals HF minus the work function. And then you get work function equals, HF, my bad. Alright, so now we want to plug away. So, we're going to use the h that we just calculated up here, so work function equals 6.4 times 10 to the negative 14th. And then we're going to multiply that by our f.
I saw it, dude.
So I did. And our f is 5, frequency, right there, 5. You can see the 5. So
Not un, dos, tres, cuatro.
No. 5. And then you multiply that times 5 times 10 to the 14th. Then you multiply that out and you get equals 3.2 times 10 to the negative 19th. Julios.
Julio?
Oh. Whoopsies.
Go.
Alright, so we did make a slight error. So, this in fact is not 6.4 times 10 to the negative 14th, but times 10 to the negative 34th. So, take that. We use the work function. Kmax is 0. So then we get work function equals HF. So, work function equals H, which is 6.4 times 10 to the negative 34th. We plug that in right there. And then we multiply that by 5 times 10 to the 14th, which is our frequency found up here. And we get 3.2 times 10 to the negative 19th joules, because work function is in joules in this problem. Circle that. Don't forget units. And then this one is on the axes above. Draw the expected graph for a different metal surface with a threshold frequency of 6.0 times 10 to the 14th hertz. So, this is basically just the same slope, but it starts at 6. So, is it good?
I saw it, dude.
It's hard. Okay, so the camera did die again, but as I was saying, it's the same slope, but since the frequency starts at 6, 6 times 10 to the 14th hertz, we started over here at this 6 instead of 5 where it originally starts. So it's the same slope, just shifted over 1. And that is it. You guys successfully just got a 5 on your physics test, but in reality you didn't, because you're just not as smart as us. And that's just the truth you're going to have to face. Did? Turn it off now.